Welcome to Spring LIB.
All right, so this is chapter 12, problem number 6 of the Smith Organic Chemistry textbook. And this problem asks us to hydrogenate 3 alkenes, and this time to take into account the stereochemical consequences of this reaction. So for A here, we're hydrogenating the alkene on the left. And we're going to get a pair of enantiomers as products. And so I do just want to highlight. So this, oops, sorry, 1 second here. All right, so this carbon actually becomes this carbon here, and this carbon here, and the enantiomer. And then let's do blue. And the hydrogens that are added are here and one of these 3. And so again, it's one of these 3, and it's this guy here. And so again, this does give us a pair of enantiomers for this problem. For B, in the same problem, we are hydrogenating the double bond in this molecule is located here. And so this carbon here ends up that carbon and ends up as this carbon. And then again, just to show the protons that are added. So one of these 3 is added by the hydrogenation. This one is added by the hydrogenation. And then so again, it's this guy and one of the 3 here. And so this gives us a pair of diastereomers when we do this hydrogenation. And it's because the distal methyl group, the stereochemistry of the distal methyl group over here is set. It's wedged. And so it's going to continue to be wedged in the product. It's not affected by the hydrogenation, but the pair of products that we get can either have a cis or a trans relationship to this methyl group. And so because we're talking about molecules that differ at 2 or more stereocenters, these are diastereomers. And then for C, again, we'll do the same thing. So the double bond is over here. And the 2 carbons that are affected by the double bond, that are affected by the hydrogenation are this carbon and this carbon. So again, there and there. And then if we wanted to show the hydrogens that were added by the hydrogenation, they would be there and one there. And then again over here, same thing, one there, one there. And again, this reaction gives us a pair of diastereomers as well. And again, here it's because we have a distal chiral center that's set. It's not affected by this reaction. And so we have 2 options for the stereochemistry at the position that is affected by the hydrogenation. And therefore, we end up with a pair of diastereomers again.